The next two examples are off of a previous video, or a previous problem. So we know that from that problem, dx dt equals sine of t cubed and dy dt equals cosine of t squared. We also know that at t equals 2, the object is at the position 7, 4. So this question is asking for what values of t, and t is between 0 and 1, does the tangent line to the curve have a slope of 4? Then we want to find the acceleration vector at this time. So this is a calculator problem. There's a good reason why. If you are looking for a slope of 4, then we want to find the slope, which is dy dt over dx dt, and find the times when that actually equals 4. So our dy dt is cosine of t squared, and our dx dt is sine of t cubed. And we're going to set that equal to 4. Now this isn't something you can actually solve by hand quickly, so you would do this with the calculator. And there are different ways to do it. On the TI-89 you can use the F2 solve button. Just say solve, set this equal to this, comma t, or if you used x as comma x, close the parentheses, and then you might want to limit your domain to 0 to 1. I think the fastest way to solve on any of the calculators is actually just use your graphing screen. So you would go to y equals, and I would set this equal to my y1. I just type it in. Now you will have to use x's instead of t's. I'd make my y4, my y2 equal to 4. And then I would go set my window from 0 to 1, so I'd only see the values that I actually care about. Now, since I'm using x's, it's my x window. The x min would be 0, my x max would be 1. Then I would graph it where these two intersect. That would actually give me my t value. It's the x value of the intersection, so that's pretty quick and easy. Once you have that, then you can find the acceleration vector at this time. Now the acceleration vector is going to be defined in components just like the velocity vector was, the dx dt and the dy dt. You can actually ask your calculator to take the derivatives for you. You can say find the derivative of sine of t cubed when t equals whatever value you got, or you can do the derivatives by hand, and I'm going to do that now because I'm not actually solving for the t. I'll leave that to you in your calculator. So my acceleration vector, let's just say we got some value of t, and I'm going to give it an asterisk. We solve for our t asterisk. To get our acceleration vector, I'm going to take the derivatives. Both of these are a chain rule. So the x component of the velocity is sine of t cubed. So when I use the chain rule to take the derivative to get my acceleration, I'm going to get a 3t squared times cosine of t cubed. And then the y component would be a negative 2t times sine of t squared. And then all that you would have left to do is actually plug in. You'd look when t equals your t asterisk, whatever that was. And that would give you the acceleration vector at that time. For our last problem, it says find the position of the particle at t equals 1. Well, we knew from a previous problem that at t equals 2, the object is at 7, 4. So I'm going to look at this in two parts. I'm going to look at the x part of the position and the y part of the position. I'm going to use the idea of start plus net change equals final. So I have my starting position, which for x is 7. My net change in position is the definite integral of my velocity, which was actually given to me. My dx dt is sine of t cubed. And my starting position happened at t equals 2. I want to know at t equals 1, so I'll integrate from 2 to 1. This would actually give me x of 1. It's the first fundamental theorem of calculus. For y, my starting y value is 4. That happened at t equals 2, and I want to know at t equals 1. So I'm doing the same thing, but I'm doing it with dy dt, so cosine of t squared. And that will give me my y at time 1. Now you need a calculator to do both of these integrals, but we're not going to do that here. But you want it to be u substitution when you integrate, but there's no t squared outside of the sign to be part of your du. The same thing here, there's no t outside of the cosine to be part of your du, so both of these need the calculator.